forget, change it, whatever you get, okay. Middle column, 3 times 1 minus negative 2. What's 3 minus negative 2? 5, but it becomes a what?
Negative 5.
Negative 5. That's what I mean. I always put the opposite sign of it. Or if you want, everyone, if this helps, you notice I always do AD minus BC. I've had students tell me before they go, Professor, that if you're always changing the middle one, then why not in the middle one? Why don't you just do this times this minus this times this? I'm like, oh, that's a pretty good idea. So if you want to do that, you can. He's like, no, I don't like that. He says it might get confused. I understand what he's saying. Hey, so let me write, I got negative 1, negative 5, negative 3. Don't do this on a test. I've seen this happen. So here's don't do on the test. Look. There's my area. This has happened before. Does that look like an area? Is a vector an area? Area has to be a scalar, right? But they're thinking of like formula sheet. What do I have to do with that?
Magnitude.
I need the magnitude. So what is that length? You know, it's got to be a positive number. It's area. That squared is what? 1 plus 25 plus 9 all over what? Well, what might take your brother or sister hours to compute, you got it in a couple of minutes. 5 minutes is square root of 35 over what?
2.
That's your area of that triangle. You can leave it like that too. You don't have to write it as a value. You leave it in that exact form.
Oh, so for Calc 3 is much easier than Calc 2.
I hope you find Calc 3 cool.
I mean, yeah, it's nice.
Calc 3 is a blast. Hey, can we do another one, everyone, from this section, dealing with this formula right here? It's also equal to torque. Okay. Let me write it here again. A cross B equals magnitude of A, magnitude of B, sine of theta. But this also equals, does anyone have a copy of the formula sheet? I want to point out where I have this. This also equals the magnitude of the torque. That's tau, so I'll say magnitude of tau. And it equals R cross F, and I'll point out what these two vectors are. Magnitude of R, magnitude of F, sine of theta. The R and F, that one, as you'll see on here, are referring to the position vectors R and the force vectors F. So R is the position vector, F is the force vector, and you're like, what does torque measure? It measures the tendency of the body to rotate about the
So the T thing is the torque?
That's right.
Okay.
And you know, it's that Greek letter like tau,
Okay.
but it's the magnitude of that is what we're going to be able to find in this next problem.
Gotcha.
But we'll just use this formula here. Force vector, position vector. Angle between those two. Well, this is that one, everyone. I didn't treat about this, but it had a wrench. And the wrench was about, let's make up another one. Let's just say this was 0.3 meters. But the angle here, I'll go like that. Go like this. Now let's just say this was 50 newtons applied to turn it. Right at origin. Now here's the position vector right here. And let's just say this was 60 degrees here. All right? The question, a bolt is tightened by applying a 50 Newton torque, 50 Newton force to a 0.3 meter wrench. Find the magnitude of the torque about the center of the bolt. You're like, well, the bolt's over here. So that always gets students when they're like, but isn't the bolt over there? There's the bolt. But I mean, here's that position vector. This is the force vector. So you don't have to do anything funny like subtract from 180 or anything like that. That's your angle. That's your force vector. And that's your position vector right there. Cool? Because you can think of this as slid right there. Let that help. So I'm going to do it. What do we get? This is just what? 0.3. This is 50. And what's this? Sine of 60. What is the sine of 60? Square root of 3 over 2?
Mm-hmm.
When I get 0.3 times 5 times square root of 3 over 2, or that's what? 1.5 over 2 times the square root of 3. What's the units? What's the units on that?
Joule?
Well, I'm going to put Newton dot meters. They always put the Newton dot meters here when we're talking about the magnitude of the torque.
Just one thing. Position vector is a vector that starts at 0, 0, right?
That's right. Great job there. And something else we got to do in this section. Now that we talked about all these formulas, cool stuff, find the area of the parallelogram, find the area of a triangle. You can use this throughout our course if you want to find an angle. Remember I said this one's awesome? To me though, you can go, I'll use this. I prefer this just because I think dot products are easier to find than cross products. Right? Dot products you can do in your head. Cross products you got to do that column thing and with your eyes. So that's why when it comes to finding measures of angles. But I've had students ask me for like, can I use this to find the angle between like two vectors? I'm like, of course you can. It's just, you might find it takes a tad longer because you do have to get the cross product. Right? Hey, there's something else we got to do in here. And I want to tell you which one I'm reflecting on. This is something like number 15. And it's also like number 6. Okay? The exercise is, when I write some vectors, expressions down, you got to tell me whether it's a vector, a scalar, or just totally meaningless. All right? I'll give you some examples. I'll take these from the book. And when vector, you want to just use a V. A scalar, you just want to use an S. And if it's totally meaningless, just use one. We'll do that. All right. 12.3 had a couple of these. Let me throw a couple down from 12.3. A dot B dot C. All right. So, some students love these, some hate these. I think it helps us build understanding. Like, when we were talking about this today, a dot product is a what? Scalar. A cross product is a what? Vector. So we can just go off in our notes and just say, well, I know that every time you got vector, dot, vector. First of all, on either side of a dot has to be two vectors, right? The result is always a what? Scalar. But if you have vector, cross, vector, either side of a cross has to have a vector. And what's the result?
Vector.
We'll just use that like that's our key, right? That's our key from now. We'll do something, even at the end of our course, we'll do something like this. You go, oh yeah, vector, cross, vector, 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 dot, vector, scalar. But you can't have like scalar next to this dot, can you? That would have no meaning. So what do y'all think here?
Scalar.
Yes, because what is this right here? That's a scalar. Can you have a scalar with a dot next to it? So what is this? This is totally what? Meaningless, right? Cool. Let me give you another one. Now this one, everyone, I didn't want this one to trick you. I'm taking this from the book. They put a magnitude of A, okay? Then they had a parentheses, B dot C. Well, what do you think? B dot C is a scalar. Isn't that a scalar?
Yeah, scalar.
So when you just multiply a scalar to a scalar, it's just a what?
Scalar.
Scalar. Very good. This right here is a scalar. Is that okay with that? And yeah, you bet. If they put a dot here, you're like, forget it. But didn't. All right, let me find the ones from 12.4. Those were a couple from 12.3. Let's get a handful from 12.4. This is number 13. They've got A dot B cross. What do y'all? By the way, when I put this on my worksheet, boldface print means they're vectors. So I use just boldface prints. I don't put the bold arrows on there. What do y'all think? Let's start here. What's that?
Vector.
That's a vector. That's a vector. What's
So
vector dot vector?
Scalar.
Scalar. So we've got a meaningless, a scalar, a scalar. We don't have to do every one of these, but let me just pick the ones that I don't want to trip you up. That was the one I was worried about. How about A dot B cross C dot A dot B cross C dot D? What do y'all think? Vector, scalar, just totally meaningless.
It's a scalar times scalar, so it doesn't have any meaning.
What do y'all think?
It's meaningless, right?
Totally meaningless. That's a scalar. You can't have a scalar inside of a what? Cross. Between a cross is two vectors, right? Hey, there's a couple that I didn't have in the textbook. You see them on the worksheet, so I want to make sure you're comfortable with these. This is why I put these on. I was like, yeah, the textbook, we're missing these. Let me start with this. Can you take a vector and divide that? Are we allowed to do that? I'm hearing it. I love it. That was thunderous too. It was loud. They knew this. This is totally appropriate. Vector divided by a what? Scalar.
Scalar, yeah.
We've done that today. Here's some examples, right? There. No, not there, because that was a scalar divide that. Let me put my arrows in there too. There's an example. I want a vector, but sometimes you have to divide a number from a vector, right? So this is just a vector dividing some value from it, or multiplying whatever the number to it. So what would this result be? Okay. Is everyone okay with that? This is just like some vector divided by like a 3. Or 1/3 times the vector. We've done that before. We do that with unit vectors. Well, here's the next one. That's one like that, everyone. Can you divide by a vector? So I'm like A cross B, and I got like A dot B up here. I think the numerator is okay, it's just the denominator, and we never divide a vector. So this is totally what? This just has no meaning.
You forgot to put the sign, vector sign. Okay, that's one.
Yeah. Art okay with that? Yeah, but this you can't divide by a vector there. Cool? Hey, I'm looking at this, everyone. Oh, one of these had you had to find the area of a parallelogram. They gave you 4 vertices. What would be your approach to that? I like it. So they gave you 4 points though, A, B, C, and D. So there's a problem in here. It had a, and like a B, and then like a C, and like a D. But they needed the points. We can work one out like this if you want me to. There's a problem to practice it like this, and you've got to find here the parallelogram. Well, you might use geometry, but these points all over the place, right? You're saying I can do this, true? But how do you make vectors from points?
Subtract them.
Just do tip minus what?
Tail.
Tail. Now, when you use one of them, I would use like vector AB, right? The other vector, I would use like AD. Does that make sense? So, hey, the problem I'm mentioning is problem number 12. They use that. -3, 0, -2, 3. C was that, but just use like, when you draw it first, just make sure you're using like these 2 vectors here. And then you'll be like, oh, I'll just cross the 2 vectors and then take the what? The length of it. That'd be an easy way. I didn't want you to think you had to do all this. Like, well, I get these, sometimes students look at me and go, I gotta get the angle. I gotta do some trigonometry and stuff. It's like, no, you said, just get cross product of 2 of those vectors, right? And then take the length. Now, this is why I wanted to talk about this problem. And let me see if I can find where it is in the textbook. Alright, they got the triangles. Hold up. And see one over here? Okay, I found it. Everyone, can you find the area? Help me find this. Find the area of the parallelogram with these vertices. A is -2, 1. B is 0, 4. C is 4, 2. and D is 2, -1. Well, can we plot all these? They said this was a parallelogram. They want you to get this area. So here's -2, 1. There's 0, 4. 4, 2. And 2, -1. So it looks something like this, right? -2, 1, 0, 4, 4, 2, 2, -1. Not drawing a scale, but can you get the area of this parallelogram? What vectors can I use?
AB and AD.
I'll do it. Now, I thought when we do cross products, these vectors have to have 3 dimensions, right? So any suggestions how we can still work the problem?
IJ.
What was that?
IJ.
Definitely use K, but what number you can use for K?
0.
There you go. Think of this as just sitting in the XY plane, right? These vectors, just put them right in the XY plane, you're like, I'm going to let that K component be 0. -2, 1, 0, and 0, 4, 0, and 4, 2, 0, and 2, -1, 0, right? You bet. That's how I look at all these points. You're in -2, 1, you're in the XY plane. 0, 4, you're 0. 4, 2, you're also 0. 2, -1, and you're what? 0. So what is vector AB?
That's 2 and
2,
3, right?
3,
And 0.
0. What's vector AD?
2 that's
2
4,
minus -2 is?
4. -1, -2.
And
And
0 minus 0?
0, yeah.
Alright. And what will I do with these two?
You want to do that.
Cross product. So what's AB cross AD? I'll just put it here. On, shoot. What do you get? Alright, what about that first column? Ooh, a lot of cross products. Well, I like 0. What's 0 minus 0? Love that. What's the third column wiped out? -4 minus 12. 16, good. What's this middle component? This times this minus this times this, then change the sign.
Yeah.
0 minus 0, change the sign. What's a -0?
0.
Now, is this my answer? Is this area? Good. What's my final step?
Magnitude.
How long is that? I'm looking at it. How long is this vector? 2 for 0.
256.
Square root of 256, which is?
16.
16. Showing the length is 16. What's the area of that parallelogram? 16. Now, think about this. The brother or sister in a geometry class would have been sitting in here like, oh man, I can get the what? I can get the height of this, get the base times the height, but what's the angle here? They're trying to figure out stuff like that. Cool. Nice. Hey, so how far did we get up to? $16, $17, $18, even up to $19, right? Well, which ones haven't I done yet? That we'll be doing tomorrow. Let's see. Before we break. We can do all the way up to number 19, is that true?
Mm-hmm.
I'm gonna look, I wanna make sure there's nothing missing. Oh, this looks good. Awesome. And then tomorrow, everyone, we'll be doing section 12.5 and 12.6. 12.5 is on lines and planes. Really important section. And 12.6 is on quadric surfaces and cylinders, which is also a really important section. But it's always good to do separate from here. Like we got up to what? Got a lot of stuff done. We got up to the dot product. It's a great place for us to stop. We'll pick up again tomorrow with the 12.5 and 12.6. Sound good? Awesome. And that's a really important section as well. This chapter 6 comes important. So, hey, if you don't want to take this now, that's totally fine. I'll make sure to bring these again tomorrow. That's a nice little summary of what's going on in 12.6. Have a great day.